Hello, this will be my submission for the Milestone 1 assignment. Um, this is the character right over here that we imported. I believe his name was White Clown, I don't remember specifically, but yeah. This is him, and these are all the animations that we imported along with him. These were all from Mixamo, and the animations were tweaked with afterwards to make sure, that their name was the right thing because they all came in as Mixamo.com. And also that the certain ones that I want to loop are looping, like the idols looping, the walk forward is looping, but they're all the ones that aren't. Where was I next? Let me see here. Show animations imported. Oh yeah, root motion. Okay, so in other projects, we were letting code move the character, but now we're using the animations to move the character. We're using movement data that's already within the animations, and we're just playing them at the right times depending on, player input. And let me see. Excuse me. Explain what is required. Okay, so in this prefab that I'm looking at over here, we have the pawn script with the animator on it, and then the player controller with the pawn script on it. So let's take a look at these two. Okay, so I should probably go through the game manager first. So game manager, I made a getter of the God object, which is, the capital I instance, and the actual God object is the private one over here. We have some player values. This one is the player prefab, and this is the clone of the player that we're going to be instantiating and having in the scene. The UI manager just keeps track of where the health is and the stamina, but that's for later. Spawn location, and then making the actual game manager right here. Okay, so we have a reference to the game manager, right? Or at least the getter, not the actual game manager, the UI one. And over here, we're gonna be accepting player input actually. On the pawn, which has the animator and the speed on it, we're gonna get the component for it, and we're gonna also receive input based on which direction the player wants to move. So if you're using a controller and you're flicking up on the thumbstick, then you're gonna be wanting to move forward, and it'll pass that in here. The way we get it, it's controller input, or at least world space movement, and we're going to be changing it to local space for the animator, so that it knows which side is forward, left, right, and back, but we're still going to be moving by that screen space. You'll see what I mean in a second. Actually, let me just show you. Go back into the scene over here. Okay, so what I meant is instead of always moving where you're facing, if you press D, which is supposed to be right, you're gonna move right, and S is always gonna be down, up is always gonna be up regardless of where you're facing. I'm gonna press up again. See? But yeah, regardless of where you're facing with this mouse, up is always going to be the same direction. So it's not locally to the character, it's just up is universal. Okay, so where was I? Okay, so in the move function, we're going to be setting the float horizontal, and that's one of the parameters that we have on the animator. Horizontal is left to right, and obviously vertical is up and down, but let me go back to, okay, so there's a horizontal and vertical in the input settings, and there's also one over here for the animator. So let me look. On by default on entry, we're going to be using base movement. Quick movement is the sprint tree. That's for running, but let's look at this first. Okay, so here's our blend tree, and it has all of the animations that we are going to be playing depending on, you know, where our thumbstick or keyboard presses. So if we're pressing lightly, then we're going to do more of a walk, but if we're doing it like really far, it'll turn into a run. Same thing with back, you know, right, diagonals too. But yeah, those are set based on these two parameters, horizontal and vertical. As you can see, I have a third one that's for running, but I'll show that one afterwards. Explain use of inverse transform. Oh yeah, okay. So let me, like I was saying, over here, with what we're passing in, we're gonna get the transform of this object, and we're gonna use inverse transform direction to change this direction from world space to local. Oh yeah, I did say that. Okay, all right. Just because the animator needs it like that. And so we can change it so that we always move up, you know, the same way. The thing I was talking about before. Okay, so character rotates to face the mouse. You already saw that, but show use of it. Explain how it works. Okay, so basically we're making the player face wherever our mouse is let me pause this. Wherever our mouse is on the screen, right? So if our mouse is to the right, then our player is gonna slowly rotate. Probably saw it before, yeah, to face wherever our mouse is, and we're gonna be using that later to shoot in other milestones. But let me go to the code. Where is it? It's on the camera controls. Okay, so this is the component that is going to go on the main camera. So the offset is basically what we're going to have to make sure that the camera doesn't follow the player exactly, because we don't want the camera like inside of the player, because we wouldn't be able to see anything. So basically we're creating a plane here, and we're using a ray cast to shoot down, like shoot a line through wherever our mouse is pointing down, and wherever point that ray touches on the plane is where the character is going to look at, basically. And that is encompassed in this function over here, and this other function is the camera using vector3.moveTowards to move to wherever, you know, to move to wherever the player's position is, to make sure, you know, that the camera's always looking at the player. But like I said before, we're going to use the offset to make sure that it's a little bit above and we're not like inside of the player. Okay. And the offset is set over here. I already put it to a 10, and it'll grab these later on. In code, I don't have to set these. Okay, so explain our vector 3. I just did that. Rigid body and colliders, gravity, collision. Okay, so first, before I do anything, he has a rigid body. He's using gravity, and there's a capsule collider on him, so he does have a collider. And let me show gravity. So the ramp that I was on before, I'm just going to go down it just to show that this does work. Up. I always walk in a weird way. Okay, so as you can see, I was at the top and I made it to the bottom. I can do the same thing, vice versa. It's just, I'm very bad at making sure I don't fall off at the wrong time. But yeah, gravity does work, and the level does have the middle portion, which is sunken in more than this wall out here. Okay, so there is gravity. Scene is appropriate for testing. Yeah, okay, so this is the scene that you saw me walking on. There's gonna be these little tunnels over here. Maybe, you know, put some power-ups inside of them or outside right at the ends. And then this will be some elevated plane for us to play on that we can go up and down stairs over here on each side. So far that's been working. Yeah, I've been commenting throughout the whole video certain places to explain, you know, what I'm doing, why, explaining that there's a getter over here of the God object instead of just one thing. But yeah. Oh yeah, and this, let me explain this actually. This is the energy, so this has to do with our UI, our stamina, and our health. These are the actual numbers, like, you know, the current health, current stamina, max you can have. These are the visuals, so the visuals that represent said numbers. And then I defined a Unity event public class over here, so that whenever the numbers change on the bars that we have, so if we're running, you know, it changes and it shows that we're running by using our stamina and also changing the blend tree. Over here on health change, that's for later because we don't really have damage right now. But yeah, and we have getters and setters for this over here, for these two, with the on health and on stamina change invoke for whenever those values get changed. And on the UI manager, which is going to be handling our UI events, it has the action cost, so this is how much we use whenever we run. Player's energy, of course. These are going to update the visuals. This is a function to find the player and grab his energy component and then start manipulating it from there. You know, add listeners to update the bars. And this is just to check to see beforehand if you have enough stamina to sprint in the first place. But yeah. And over here, the rest of this, didn't explain before, this is for sprinting. And this is where we check, you know, can sprint true? Do we actually have stamina? If not, and we're not doing anything, then stand still and recover stamina. Let me show that. Let me show the difference between the normal tree and the running tree. So right now, I'm using the normal, you know, just walking, and my stamina is the same, right? But if I hold space, then I'm going to start using the other one, running more haphazardly and a little bit faster. But it's also using my stamina. But if I stand still and do no actions, but just turn around, it'll slowly recover it around me. The green is for your health, but that's going to change later when I actually have damage. It's going to go from green to yellow to red later on. But for now, what I have is fine for its purpose, I say. But yeah, that was the running tree. So that was the... Well, where is it? Yeah, new mechanic, above and beyond. And also I had to show the stamina working. But yeah, that is my Milestone 1 project. Thank you for watching.